Okay, so for 2.4, we are solving systems of equations graphically. Systems of equations should be a term that you've heard before. There are multiple ways to solve systems of equations. When you're solving with algebra, you would have done elimination, substitution. We are going to do those strategies as well. But you can also solve by graphing. So when you are graphing the related function, the solution for the system is going to be the point of the intersection, which means your solution should always be a point if there is one solution. Okay, we're going to find out today. You can also have infinitely many solutions. You can have no solution. Okay, so we're going to be looking at the graphs for those today. Okay, so you should have the point xy of the intersection there. And then what we're going to do is we are going to draw our graphs for each of these. Okay, so it's the point xy of your intersection. So in each of the first three boxes, we're just going to start by drawing a grid. Okay, so we're going to draw an XY grid here. Oopsies, maybe I should be using my straight edge for that. Okay, these are just going to be rough sketches that are going to model our situations. Okay, so we're going to label X and Y. That does look so much more beautiful, doesn't it? Okay, so the first type of graph is going to intersect at one point. So we're going to say that this intersects at one point. I'm using my @ symbol. So it intersects at one point xy. Okay, so on our graph, we are just going to draw two lines that intersect each other. Okay, your lines don't have to be exactly where mine are, but they should cross each other and meet in a point. Okay, this point of intersection is our solution. Okay, so when it intersects in one point, that means you are going to have different slopes. So if you examine the equation, which remember our equations are going to be in the form y equals mx plus b. We are going to have linear equations here. And if they cross, it's going to be one solution. And then we are going to classify those. Okay, so if it is one solution, we would classify the system as consistent and independent. And we're going to talk about this a little bit more once we fill out the chart. So it's consistent, this is my and symbol, and independent. Okay, consistent and independent. Okay, and then the next line we're going to do is the same line. When you have the same line, that means you have the same slope and the same y-intercept. Okay, when they overlap each other, because lines have an infinite amount of points, this means there are infinitely many solutions. Okay, will you guys nod if you've heard that before, infinitely many solutions? Is that a term you guys have heard, infinitely many? Okay, and again, that's because they overlap at every single point. So we also call that type of system consistent, but this is a dependent system. So the classification is consistent and dependent. Okay, and then let's graph that one. Whenever I graph the same line, I like to graph one of them and then I'll use a highlighter for the second one so you can see that they overlap one another. Okay, and if you didn't get the bottom one, I am going to move it up in a moment, so just be patient. Okay, the last set is going to be parallel lines. And if you have parallel lines, you guys might remember from geometry that they do have the same slope, but because they're not the same line, the y-intercepts are different. So you have a different y-intercept. So if they never intersect, then there's no solution. Okay, and then you guys can draw a pair of parallel lines. Okay, so you have parallel lines, same slope, different y-intercept. There's no solution, and if there's no solution, we call it inconsistent. Okay, inconsistent. So when you are classifying, it is consistent if there is a solution, and if there's no solution, it's inconsistent. Okay, the second part, if it's independent, it means that it can stand alone. So I always think one solution, one is alone, so that's going to be independent. Because you have infinitely many here, then it's going to depend on which point you have, okay, on which value, x value you have that's going to give you your y. So if it's dependent, there's many. If it's independent, there's one. Okay, so there's an infinite amount, so that's going to depend on your situation. Okay, so we are going to use this to help us with our first example. So if you flip the page, you're going to see that we have to determine the number of solutions. Okay, and then we're going to decide if it's consistent or inconsistent, and whether it's independent or dependent. Now remember, if it's inconsistent, you don't have to classify it as independent or dependent. Okay, so the first thing we're going to find are your number of solutions, then we'll classify. So let's look at our two equations. These ones are both in the form y equals mx plus b. So I'm going to look at my slopes. I have the same slope, okay, and then my y-intercepts are different. Okay, so if it's the same slope and the different y-intercept, if you need to look at that chart, go ahead. Okay, so same slope, different y-intercept is going to give you parallel lines, which means there are how many solutions? Yeah, so if there's no solution, you can just say 0. That's how the book will say it as well. Okay, so the number of solutions, there's 0 solutions. Okay, if you put none, I would not mark that wrong, just so you know. Okay, and then this would be inconsistent. So whenever there's no solution, it will be inconsistent. All right, and then when we head over to part B, we can see these are not in the form where you can pick out that slope and y-intercept right away. So I recommend putting it in that form first. Okay, so your steps for these are to make sure it's in this form. Put it in the form y equals mx plus b. And then you are going to compare the slope and y-intercept so that you can classify. Okay, so I'm going to give you a few moments right now. You can take these and put them in the form y equals mx plus b. That is something that we did on the last test, so I know you guys can do that. So go ahead and put it in the form y equals mx plus b. And I know you guys are going to work at different pieces, so if you do finish that quickly, feel free to go to the next one. Alright, let's see how we did. So remember, whenever you're moving something over the line, you do want to subtract it. Okay, and I'm okay if you just go here, but sometimes it's easy to make some of those small mistakes, so writing it out can help as well. And then whenever you're dividing, a negative divided by a negative is a positive. Okay, so these are little rules sometimes that when we get to an assessment, sometimes we second guess ourselves. That's why we want to make sure that we practice and that we know those little algebra rules that you guys have been practicing for a while. Here we just have to move over the 2x. Now we can compare. Okay, so once you see that the slopes are different, there's only one situation where you have different slopes, and that's where you have one solution. Anytime you have a solution, it's consistent. And if there's one, is it independent or dependent? Independent. All right, and then for the last one, we have 4x plus 6 equals negative 10y. If you're solving that for y, you can just divide by negative 10 at the start. You can get y by itself on this side, that's fine. But when you have 4 over 10, you have to remember that that can be reduced. 2 goes into both, so it's a negative 2/5 x. 6 over 10, 2 goes into both, positive over negative is a negative. Divide by 2, divide by 2. Okay, so this would be one of your equations. Okay, and then for this one here, 5y plus 3 equals negative 2x. We would subtract 3 from both sides, then divide by 5. Again, make sure you're dividing both of those by 5. Okay, and then if they're the exact same, then there's infinitely many solutions. Abbreviate solutions like I do. And anytime there's a solution, it's consistent. If there's many, it's dependent. All right, and then the next one says we are going to solve by graphing. So this year we have already done graphing of linear equations. So the first thing we're going to do is just make sure that those are in the form y equals mx plus b. So if I have y plus 3x equals 3, I just have to move over the 3x. And now I'm ready to graph this. Okay, so that means I'm going to start at 3. And then this is like negative 3 over 1, right? So if I go down 1, 2, 3, I go to the right. 1, 2, 3, go to the right. 1, 2, 3, go to the right. And then I can go 1, 2, 3 up, go to the left. 1, 2, 3 up, go to the left. Okay, we want at least 5 points on there to connect. And then you can use your straight edge to span your grid here. Okay, and then here, the only thing you have to do for this to get y by itself is divide by negative 2. So if you do that, you have negative 3x. 1 divided by negative 2 is negative 1/2 equals y. So we're going to start at negative 1/2. That's your intercept, your y-intercept. We're going to go down 1, 2, 3 over 1. 1, 2, 3 over 1. Up 1, 2, 3 over 1. 1, 2, 3 over 1. And then we're going to use our straight edge. Okay, now this does say to solve by graphing. So because we know how to do this without graphing, like you might know what your answer is just at this step, but you do have to do your graph for anyone that says to solve by graphing. Okay, so for here, it's going to be no solution. There's no intersection here. Okay, so the lines are parallel. Okay, so you have parallel lines. Anytime the lines are parallel, no solution. All right, and then for B, for this, you do not have to write that. So if it doesn't ask you to classify, it's just asking you to solve. You just have to put no solution, what the solution is, or infinitely many. Okay, so if there is one solution, we will say what that solution is. So for this, I'm going to add 2x to both sides, which is going to give me y equals 2x plus 4. Okay, so then I have 4 is where I'm starting. I can go up 2 over 1, okay, or I can go down 2 left. Make sure you're doing that check to say, hey, do I have a positive slope or a negative slope? And does my line follow that direction? So if you have a positive slope, we should be going up from left to right. Okay, we are going to span that grid there. And this is already in the proper form. So I can just start at negative 6. I can go down 1, 2, 3 over 1. I can go up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And you really should keep going until you see them cross, if they do cross, so that you can see what your intersection is. Okay, so for this one, your solution, there's one solution because they do meet, and you have to say what that is. So you have to give your x and y coordinate. Okay, so this is your point. On the x, it's over negative 2. On the y, it's at 0. All right, and then I want you guys to go ahead and do speed. Again, keep in mind, I know some of you are working at different pieces, so if you finish that early, feel free to check out the story problem on the next page, okay? Okay, so we're putting that in the proper form. Go ahead and graph. All right, let's see how we did. Okay, so when you guys are solving, we're moving over the -2. We're dividing by -4. When you divide a negative by a negative, it's a positive. So, and then you're going to reduce. So -2 over -4, 2/4 is 1/2. -6 over -4 is 3/2. And a negative divided by a negative is a positive. How did that go? Because you had reducing, and then you also had different signs on there. Okay, and then here we added the 9 over, then divided by 6. So again, we're going to reduce. 3/6 is 1/2. 9 over 6 is 3 over 2. And then don't be afraid of 3 over 2. 3 over 2 is just what number? Yeah, 1.5. So I'm just going to show you, if you start at 1.5 and you are going up 1 over 2, up 1 over 2, you're just halfway. Okay, and then you can go down 1, back 2, down 1, back 2, and then you're using your straight edge for that. Okay, and then like I said, whenever you have like a line that's going to overlap, just use your highlighter on that. Okay, and then you'll have infinitely many solutions. Okay, and then once you have that, let's go ahead and look at example 4. So that is a story problem. Okay, and when you are doing the story problems, sometimes it might help if you look at what you're trying to find first. So we're going to try to write equations for the total number of pages each student reads on Saturday. Okay, so Pedro and Bella are reading the same book for their language arts class. On Saturday, Pedro starts at page 20, reads at an average rate of 25 pages per hour. And then Bella starts reading at the same time, but she starts at page 60 and has an average rate of 18 pages per hour. Okay, so do you guys think you could write a sample equation for each person? One for Pedro, one for Bella? Okay, so we're working with linear equations here. You have a rate and you have a starting point. Okay, the rate is going to go into your equation for what part? Yep. And then where they start is the y-intercept. So 25x plus 20. Okay, so it's just his rate. X would represent what? What would X represent here? Yep. And so when we do our scale, we're going to label that. Okay, and then this is where you start. Okay, so then Bella's rate is 18 pages per hour. She starts at 60. Okay, so we're going to graph the equations on the same coordinate plane and examine the graph to estimate after how many hours of reading will they be at the same page in the book. Okay, so when we're doing this, because we have a real situation, we are just going to use the positive axis for X and Y. Okay, so we're going to have the number of hours here. So your hours, I'm just going to go by ones, and I'm just going to label every other one. Okay, and then these are going to be the hours. Before I do my label on the other side, I want to get some data points so I know what I'm graphing. So I'm going to make a table for Pedro, and I'm going to make a table for Bella, so I can make sure I have a good amount of points to connect these lines. Okay, now this we're doing without our calculator, so I would always start with 0. If you plug in 0, what do you get? Okay, now when you plug in these values, see how you're going to multiply it by 25? When you're doing story columns, you do not have to do like every single one. Like you do not have to do 1, 2, 3, 4, 5 in order. And in fact, we're going to want to span to 14, okay, or at least close to that. So I'm going to pick some other values. I know 25 times 4 off the top of my head. What is it? What's 25 times 4? 100. So 100 plus 20, 120. So sticking with that theme, I might try 8, because if 25 times 4 is 100, what's 25 times 8? 200, right? You're just doubling that. So 200 plus 20 would be 220. Okay, 12 isn't going to be so fun, but I could do 10. What's 25 times 10? 250. 250 plus 20, 270. Okay, so see how I've now created some points using mental math, and it's okay that they're not all going by the same amount. Okay, I have a good amount of points where I can graph that line now. Okay, so for Bella, I'm going to start with 0, which is going to be the y-intercept of 60. And then I'm going to stick with the same thing where I'm going to plug in 4, because I can just know, use what I know about doubling. If I double 18, what do I get? 36. So you just have to double that. So what's 36 plus 36? Yep, so this is just 72 plus 60. So 70 and 60 plus the 2. Yep. Okay, now if you do 8, remember how we plugged this in? It was 100 and then here it was 200? It doubled. So if you're doubling this, you just have to double the 72. Okay, so what is 72 doubled? 44, and then you're just going to add your 60 to it. Okay, now could you also just like plug it in and multiply it out? Yes, but I'm just showing you how you can use some of these shortcuts with number problems. And then with 10, 10 times 18, 180, 180 plus 60. Yep. Okay, so now I can start to think of a scale that's going to make sense for my y. So I probably want to go up to about 300. So if I want to fit that in, what do you think? We go by 20. And then when you're using graph paper, like you can extend it however you want. So we have 20, 40, 60, 80, 100. I'm just going to label every few. And then 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. Okay, and then remember, y is going to be the amount of pages. And now we're ready to graph. I'm going to do this with a pencil, just in case I can make a small mistake. We can erase it. And know that there's always, when you're making a graph, there's always a small margin of error. So your answer might be a little bit different than somebody next to you, and that's fine. So at 0, 20, that's where we're going to start. And then at 4, I'm at 120. At 8, I'm at 220. And at 10, I'm at 270. So that's going to be halfway. Okay, and this is a situation where the straight edge really comes in handy because you're connecting those points, and we're going to use them to estimate. Okay, now Bella's, this is where the margin of error is going to come in because we're going to have some values here where we're going to have to do estimating. So we have 0.60 to start, and then at 4, we're at 132. So here's 120, here's 140, 132 is going to be close to the middle. I'm just putting a small point there. And then for 8, it's going to be 204, which is really, really close to 200. So I'm putting my point there. And then at 10, I'm going to 240, which is right here. Okay, and based on what I have, the lines are going to cross each other, which is what you need to happen. So if you start graphing and the lines are not crossing, you are going to have to do more points so that you can see the lines intersect. Okay, and then you are going to find on your graph where they intersect. And keep in mind, your point might be a little bit different than somebody next to you, and that is okay. Yeah, so mine look like they intersect about here. So kind of close to 6, but not exactly 6. And it's okay if you round, or it's okay if you say like 5.8. Okay, you can decide. Okay, so I'm going to say for this approximately 6, but I'm also going to show you what happens if you use a decimal. And remember, your T is your time, so this is about 6 hours. Now C says to check your estimate. You have to answer how reasonable it is by justifying your answer. Okay, so we're going to write out an explanation, and when we check the estimate, we just have to plug these into our equations. So if I check this into Pedro's, which is y equals 25x plus 20, I'm going to substitute in the 6 hours. And for Bella, I have 18 times 6 plus 20. Okay, so I want you guys to think about some mental math strategies that, this should be 60, and there's no parenthesis here. So 8 times 6 plus 60. Okay, so can we do the first one using some mental math? So it's 25 times 6. Why don't we know 25 times 4 is what? Is 100. So if we have 2 more, yep, it's 150. So 150 plus 20, 170. When you're doing a number that's not as nice as this, you can just do 10 times 6. What's 10 times 6? 60. So it's 60 plus 8 times 6. Okay, so then now you can just add these 3 numbers together. Okay, so 60 and 60 is 120, 120 and 48, 168. So what do we think? How reasonable is our estimate? Yeah, that's really good. They're only 2 pages apart. Okay, so how reasonable is your estimate? My estimate is very reasonable because, so I'm just going to put my VC. Okay. At 6 hours, Pedro and Bella are only 2 pages apart. Okay, now we rounded to 6. When I did this before, I my graph actually showed more of 5.5, and I plugged that in, and I was only 1.5 pages apart. If I was being technical, I might plug in like 5.9. If you have something like that, please feel free to use your calculator. So like if I plugged in 5.9 plus 20, okay, I'd have 167.5. If I plugged in 18 times 5.9 plus 60, okay, oh, those are really close together. Okay, so I would say in my reasoning that Bella would be approximately on page 166, okay, and then 167, or you could say halfway on page 168. Again, you could find the difference between them, okay, and say they're only 1.3 pages apart, okay? So if you have just some decimals there, please feel free to calculate those with your calculator. All right, now on your next assessment, you're going to be able to use a graphing calculator, and you are going to have to use it to solve these systems of equations. Okay, and when you are rounding for these, we are going to round to the nearest hundredth. Okay, so when you are doing these, I'm going to write out for you the steps that you're going to have to take in your calculator. Okay, the first thing we're going to have to do is put them in the form y equals mx plus b. Okay, so write these steps out with me. So the first thing is in y equals mx plus b form. Okay, after we do that, we are going to plug each equation into your graphing calculator. Okay, and I'm going to teach this to you like you have never seen a graphing calculator before, because I know some of you have never graphed on a graphing calculator before. So if you hit the y equals button, you are going to see some spaces where you can plug in each equation. I'm just going to abbreviate equation. Okay, and then you are going to graph it. And graph is the button. Anytime you press a button, I like to make my little button there so you know what you're pressing. Okay, so we're going to do those together, and then we'll write down what our final step is. So we're going to take this equation, 2.5x minus 1.9y equals 24. And we're going to put that in the proper form. So when I move over the 2.5x, it has to be negative. Minus it from both sides. And then we're going to divide by negative 1.9. Because it tells me to round to the nearest hundredth, I'm going to make sure I do that. So I have y equals, and then if I see they're both negatives, when I'm typing this in my calculator, I don't even worry about that. I know it's going to be a positive. So it's 1 point, and then the 3, 1, but you have a 5. So that presses that up, pushes it up to a 2. Okay, if it's 4 below, it would stay. And then same thing, I don't worry about the signs when I plug it in. I just do the sign myself. I know a positive divided by a negative is a negative. So this is going to be 12.63. Okay, so that's one of my equations. And for my second equation, we are going to solve for y, so we're going to get the 3.2x to the other side, divide by 6.1. Okay, so I want you guys to practice dividing and rounding. Okay, make sure you know those rounding rules. Okay, 5 or above, it's going to go up. You always look at the third spot if you're rounding to the nearest hundredth. Okay. Okay, so when you divide, you should have got 0.52x plus okay, and that one's going to round up. Okay, so what I wrote here is you go to y equals. Y equals is right here. I'm going to plug these in with you. Okay, now for y1, we're going to plug in the first equation. Also, make sure none of these are highlighted. If they are, when you try to graph, it will give you an error. That if it looks like this, it's highlighted and you don't want that. Okay, so you have 1.32. The x button, you're going to use this variable. See, it says xt, it's a theta and an n. If you press it, it'll give you your x. That's your variable key, minus 12.63. And then for this one, we can put in 0.52 x plus 0.33, and then go ahead and hit your graph button. Yeah, so both of these are going to be linear. So when you graph, you should see two lines there. Oops, sorry. When you're doing this, okay, you're going to start in a standard window, a 10 by 10. Okay, so here's this graph. It's going to look like this. Okay, if you ever need to go back to a standard window, just go to Zoom and then 6. That gives you the standard window. Okay. But what we want to see is we want to see where these two are intersecting. So do you guys agree that I have to see what's happening over here? So that means my x values are going to have to be what? Bigger. My y values, I guess my y values don't even really need to be bigger. So if I go to my window, I need my x values to be bigger. So what I did is I hit window, and I'm going to adjust that. So if my x values need to be bigger, go to x max. Let's just do 50. You can pick whatever you want, okay? But then when you have this is x scale. It means what do you want those tick marks to go by? So whenever I raise that, I just raise my scale as well, okay? And then you should be able to see the intersection. That is kind of close to the screen, so I might go back to my window and say, hey, I want to see more of my y, and maybe I'm going to raise my y to 20. And then maybe I make my scale by 2s. Okay, and then that's going to be your tick mark. And then now we can see our intersection there. Okay, so again, what I did is adjusted my window. So you are going to have to adjust your window. Okay, to see the intersection. Yep, so if you go to your window, if you can see, hey, I want to see what's happening over here, make your x's larger. If you want to see what's happening on this side, you make them smaller. Okay, so that is something that you're going to have to play around with a little bit. And then once you do that, to find the solution, we are going to hit the following keys. So I'm going to put them in button form. You are going to hit the second button, and you are going to hit the trace button. So they used to be all capitals, and now they're all lowercase. So that's why I write it like that. I'll try to change my stuff. Okay, and then once you hit that, for most of these, it's going to be option number 5 that says intersect. We're going to press enter 3 times until it says intersection. That's the key word. Okay, so we're going to hit second, trace. Okay, so the trace is going to be right here. So I'm going to press second, trace. Okay, and then we're, you can either arrow down to 5, or if you just press 5, it does it for you. So intersect is 5. Okay, now you have to press the enter. Do you guys see there's a question down here? Will you guys look at this? Because this is the question I got the most today. So see, it's asking you first curve. It's saying, where does the first curve meet the second curve? So we just try to put it right on that intersection. We press enter. And then once you press enter, it says second curve, question mark, and we press enter. And then it's going to say guess, and we're going to press enter. So see how we press enter 3 times? Okay, once you get it on that point, you can do enter 3 times, and then see this word here. I'm going to zoom in. Okay, it says intersection right on there. So the intersection is going to be your solution. Okay, so the intersection is your solution. So it is 16.2, and then it said to round to the nearest hundredth, so we are going to round to 0.75. Okay, this is your final answer. Okay, so you definitely want to make sure that you are practicing with your graphing calculator. Okay, you want that muscle memory for when you go to your test, okay? All right, and then the second thing we're going to do with our graphing calculator is we are going to solve each equation by using a system of equations. And again, we're going to round to the nearest hundredth. Okay, if you are having trouble getting this intersection on yours, I will walk around in a minute, so don't get rid of it. I'll help you. Okay, and then what we're going to do for this, the first thing we're going to do is we are going to write 2 equations. That is your system, because it says using a system. So write 2 equations. That's your system. And those 2 equations you're going to plug in for y1 and y2 into y equals, and then you're going to graph. Whenever you are graphing, you are going to have to adjust the window as needed to see where they cross. Okay, so you're going to adjust the window to see intersection as needed. Okay, to do that, you just hit the window key. Okay, if you make a mistake on the window and you go to graph it, it will say invalid dimensions. So if you see invalid dimensions, you got to go back to your window and check those. Once you do that, the directions are very similar to what we did above. You're going to go to second. You're going to go to trace. You're going to smash that intersect button. Just kidding, don't smash it. Okay, and number 5 is intersect. And then how many times do we press enter? 3. Okay, the only difference is this time you are solving for x. So you are going to find the x value, and that is your solution. Okay, so because you are solving the equation here, okay, you are solving this for your value of x. Okay, so when you write your 2 equations, sorry, give me a second. When you write your 2 equations, on one side of the equation, that's your y1. So your y1 is negative 92.21x minus 15. Okay, your y2 is 18x plus 59.03. This is your y1, this is your y2. so now we're ready. Y equals. Okay, so I have negative 92.21x minus 15. I have 18x plus 59.03. Oh, no. Yeah. Now we're going to graph. Okay, so when you graph it, okay, I can't see the intersection. If you guys want to go back to the standard window, you can go to zoom and then 6. Okay, and then you can see, hey, I want to see what's happening up here. So I'm going to have to make what more? The Y max, yep. Okay, so let's get crazy. Let's go to 100. Let's make our scale by 10s. Let's see if I can see anything there. Yay, I can see it. Ooh. So once you can see the X, you are good. Okay, we're just going to press second, trace, intersect, and then it says first curve. So you want to see your value. So if I keep going to the left, it's getting more negative. I want my Y's to be positive. There it is. Okay, and sometimes you can't get directly on the point. That's okay. If you just get it close to it and you press enter 3 times, they will give you the intersection. Okay, so then your X value, we're going to round it to the nearest 100, and it is approximately negative point. Go ahead, you know you want to say it. 67 is a whole lot of being weird. I know, come on. Okay, so negative 0.67. When I forgot that this was the answer to it, so in the earlier class I was like, oh gosh.